is Allan Cupertino. I conducted my research in Federal University of Minas Gerais, Brazil. I also worked in Aalborg University as a guest PhD. In my research, I'm looking for reliable and efficient STATCOMs. Why? Because STATCOMs have been widely used in solar and wind power plants to provide the low voltage high true capability with a requirement of the modern grid codes. The STATCOM costs are divided into capital and operational expenditures, CAPEX and OPEX. OPEX is affected by the converter losses and the maintenance. Therefore, the focus of my thesis is to propose reliable and efficient STATCOM systems to reduce the total cost. The Modular Multilevel Converter is selected because of its high efficiency and inherent fault tolerance. The failures in power electronics components can be classified in wear-out and handle failures. Semiconductors and capacitors are responsible for an important percentage of failures. To deal with the components wear-out, I proposed a reliability-oriented design for an MMC-based STATCOM. The design inputs are the converter ratings, the operating mission profile, and the reliability target. Then, the thermal stresses and accumulated damage are estimated. Different part numbers and ratings can be compared. Both CAPEX and OPEX are taken into account. The design which reaches the reliability target with the minimal cost is the most suitable for the application. On the other hand, redundancy strategies are commonly used to deal with random and overstressed failures. When a failure is detected in a converter cell, it is replaced by a redundant cell. However, redundant cells increase the converter cost. Under such conditions, I propose to explore the overmodulation region as a fault tolerance strategy. Usually, the overmodulation region is avoided due to the increasing harmonic distortion. Nevertheless, when the number of cells is high enough, MMC is modulated through a staircase scheme, nearest level control for example. Therefore, the increase in the THD in the beginning of the overmodulation region is negligible. Based on this proposal, an MMC with 26 cells can operate after 4 failures without exceeding the recommended harmonic distortion levels. As conclusions, the reliability-oriented design can reduce the wear-out probability of STATCOM systems. And the fault tolerance scheme based on overmodulation can reduce or even remove the requirements of redundant cells. These developments lead to cost-effective and more reliable STATCOM systems. This research resulted in 13 journal papers and 5 conference papers. Thank you for watching.